Hey guys, my name is Marek and welcome to my channel. So this is the first video of the channel and I thought what would be the best way to start than just going through the AI fundamentals overview, simply about what we are actually all talking about and working with, and we'll be probably working in the next time ahead of us. So in this video I would like to go briefly through the definition of the LLM, RAG, AI agents. So the contents would be the definition of the LLM, then how LLMs are trained, and what is RAG, how it works, and how it's actually very important, and what is a modern AI agent. All right, so let's get to it. So the definition of the large language model is that it is an advanced AI system that understands and generates human-like text. It's trained on massive amount of data, allowing it to answer questions, write comments, summarize information, and generate code. LLMs use deep learning to predict the next word in a sentence, making them powerful for tasks. You know all, ChatGPT, Claude, Gemini, Grok, and all that. All these are the large language models which we are actually interacting and using every day. So the characteristics of the LLMs. They are trained on the massive data sets, as we said. They learn from diverse data sources like all the books, articles, and code repositories, enabling them to generate contextually rich and informed responses. They use billions of parameters, like LLMs have billions and or even trillions of parameters, which actually applies to ChatGPT, which are the initial settings that determine how the model processes and generates text. These parameters act like neurons in a neural network, capturing complex relationships between words, phrases, and context. The more parameters the LLM has, the better it can understand nuances, generate coherent text, and adapt to different topics. For example, ChatGPT is estimated to have over 1 trillion parameters, and I think it's even more, something like 1.7, enabling it to produce highly detailed and context-aware responses. Now, another thing to understand or to summarize is that there is something called natural language processing and NLP. Like every time you ask ChatGPT a question, get an AI summary or translate the text or whatever have you, you are actually using natural language processing. So NLP is the technology that enables machines to understand, interpret, and generate human language. LLMs are then the most advanced application of natural processing, language processing. Think of NLP as the foundation and the LLM as the supercharged brain built on top of it, capable of reasoning, answering questions, and adapting to various contexts. Another very good analogy is actually the human brain and maybe the synapse analogy, right? So the context of an AI model can be compared to the way the human brain processes information. Just as synapses connect neurons and enable learning, in AI models, parameters act as the elements through which it learns from data and generate predictions. In human brain, the synapses transmit electrical and chemical signals between neurons, strengthening or weakening based on experiences, and this is how learning and memory are formed. Similarly, in an AI model, parameters are adjusted during training to reduce errors and improve accuracy, effectively learning from the data it processes. So the more parameters an AI model has, just like more synapses in a brain, the greater capacity to learn, adapt, and handle complex information. Okay, so how these LLMs are actually trained. So they are compressing internet data into intelligence. So training LLM is actually far more complicated than just simply using it. Training an LLM is like compressing all these vast knowledge of the internet into a format that an AI can effectively process and generate responses from. This process involves key stages like this. First, there is a data collection, gathering the internet's knowledge. This data forms the foundation of the model's knowledge, helping it learn language structures, facts, and reasoning patterns. Then we have tokenization, breaking language into pieces. So before an AI can understand text, it must be broken down into smaller units called tokens. Tokens can be words, subwords, or even individual characters depending on the model. For example, the phrase hello world might be tokenized at hello, comma, world, exclamation mark, which actually gives it like 4 tokens. Then we have the vectorization, converting text into numbers. So since AI doesn't process text the way humans do, each token is transformed in a mathematical representation, a vector. These vectors capture the relationship between the words, such as synonyms, context, and sentence structure, allowing the model to understand meaning beyond just individual words. The next stage is the compressing through learning, finding patterns and storing knowledge. So instead of memorizing every sentence, LLM use deep learning to recognize patterns in language. Through a process called self-supervised learning, the model predicts missing words or next tokens, gradually refining its understanding. This is done using neural networks with billions of parameters, or even trillion, as we mentioned earlier, which act as a compressed representation of the data, storing essential language patterns while discarding unnecessary details. So, for example, after reading numerous articles about weather patterns, a model doesn't retain the exact text but understands the relationship between temperature, humidity, and the likelihood of a rain. This allows it to make intelligent predictions and generate meaningful responses based on learned insights, rather than recalling specific phrases. Imagine the internet contains millions of articles on some topic, whatever topic you choose. Directly storing and recalling all of them would be very impractical. Instead, during training, the AI model compresses the knowledge from these articles into a set of parameters, a mathematical representation of the patterns and relationships. Later, when asked about the topic, the model doesn't retrieve specific articles, but uses its learned parameters to generate responses that reflect its understanding of the topic. This process allows AI to distill vast amount of data into a flexible and efficient format, enabling it to answer questions, generate text, and perform language tasks without needing direct access to the original sources. Now, when we have all that, we go to something called fine-tuning and optimization, making the model smarter. So, after the initial training, LLMs are fine-tuned on specific datasets to improve accuracy, reduce biases, and align their responses with desired behaviors. Techniques like reinforcement learning from human feedback help the model generate more helpful and contextually relevant outputs. Think of it as giving model a mini course on particular subject or style, helping it become more expert in the area. So the good example could be like if you decided to learn Italian language, for example, you begin by immersing yourself in the language as broadly as possible, listening to Italian music, watching Italian movies, reading Italian books. And this stage is similar to pre-training phase for the LLM. So just as you are absorbing Italian from various sources without focusing too much on specific topic, pre-training processes and the LLM expose LLM to a vast array of text from the internet. This broad exposure helps the model, or you as a learner, grasp the fundamentals of the language, which is grammar, common vocabulary, sentence structure. And it's about building a general understanding and the ability to comprehend and generate the language across many contexts. Now, after months of broad learning, you decide you want to focus, let's say, on the Italian cuisine because you plan to open a restaurant. This is where fine-tuning comes in. To specialize your Italian, you might start reading Italian cookbooks, watching Italian shows and cooking shows in Italian, and then practicing speaking about cooking with Italian-speaking friends or tutors. You'll focus on learning vocabulary specific to cooking and food, which will make you more proficient in discussing Italian cuisine while still retaining your general Italian skills for other contexts. And similarly, in the fine-tuning phase of the LLM, the model is trained on a specific dataset relevant to a particular task or domain. For instance, if the model is being fine-tuned to give medical advice, it will be training on medical textbooks, patient consultations, and other related texts. And this helps the model become more proficient in generating text related to the medical field, improving its ability to respond accurately to medical queries. Now, in both cases, the broad fundamental knowledge gained during the pre-training phase is crucial, but it's the focused, specialized practice, whether in a language or a domain, that enables the learner or the model to excel in those specific areas, becoming more effective and efficient for particular tasks or conversations. And now, once all that is done, we have the final result, which is actually a knowledge-packed AI that generates human-like responses. By compressing massive amount of text into a structured mathematical model, an LLM can generate coherent, context-aware responses, answer questions, and solve complex problems, all without needing direct access to the original training data. And now this is what we all use and know are the LLMs like ChatGPT or Claude or Gemini or Grok. This is all what they are actually have to been through, so we can have the perfect results that we have right now. So now the next topic is the RAG and what it actually is. So retrieval augmented generation RAG is an AI technique that enhances language models by combining retrieval-based search with text generation. Instead of relying solely on pre-trained knowledge, a RAG model dynamically fetches relevant external information from a database, document store, or search engine before generating responses. So how RAG actually works? First, we have a retrieval. The model searches for relevant documents or data from an external source. Then we have augmentation. The retrieved information is fed into the language model as additional context. And then we have a generation. The model generates a response based on both its internal knowledge and the retrieved data. The benefits of RAG are improves accuracy by incorporating real-time or domain-specific knowledge. It reduces hallucinations by grounding responses in verified sources, and then enhances explainability by linking output to external references. If an AI agent does not have RAG, it would rely only on its pre-trained knowledge and internal parameters to generate responses. This leads to several limitations, right? It can have outdated info, stuck with old data, no real-time updates, then hallucination risk, no fact-checking, just confident guesses, then weak on niche topics like struggles with specific queries, no real-time learning, cannot adapt to new facts without expensive retraining, and then no source validation, can't give sources, making trust verification difficult. So without RAG, AI is basically static, unreliable for dynamic info, and hard to trust. So here's an example about with the RAG or AI without RAG and AI with RAG. So if I ask today's weather to the AI without RAG, it would answer something like, I don't have real-time data, but generally February in London is cold. And in contrast, an AI with RAG would retrieve live data, access up-to-date documents, and cite sources, making its responses more reliable, specific, and adaptable to new knowledge. So with RAG, with the same question, we would get something like, today's weather in London is 8 degrees Celsius with light rain and moderate winds. Here's the latest forecast from the UK Met Office, right? So with RAG, the AI can retrieve the up-to-date, dynamic, specific, and real-time information from external sources, ensuring the high accuracy, relevance, and reliability in its responses. So, and lastly, I would like to go through the definition of an AI agent, because there is something which we are all talking about and are building. So it's very important to understand it also. So I think the definition can go like something like this. the AI agent is an autonomous system that perceives its environment, processing information, and takes actions to achieve specific goals. It typically operates using machine learning, natural language processing, and decision-making algorithms to interact with users, other systems, or a physical world, right? The key characteristics would be autonomy, perception, reasoning, action, and learning. Now, the key difference between AI agent and AI assistant could be that AI assistants are mostly reactive and command-based. Like, for example, if you recall, Siri and Alexa respond only when prompted. They follow pre-programmed rules and lack deep reasoning or autonomous adaptability. So, for example, Siri can set an alarm or answer a fact-based question, but it won't plan your day or solve complex tasks by itself. On the other hand, AI agent is proactive and autonomous. AI agents can act independently, making decisions, executing tasks, and adapting based on real-time data. Unlike traditional automation, modern AI agents leverage LLMs and RAG to learn, reason, and refine their actions dynamically. And this is actually what we are actually striving for. This is what is the AI revolution about. This is what we are actually all want to build and have our own agents for our own tasks. So an example could be an AI co-pilot that, for example, books travel, manage emails, and optimize schedules without needing constant instructions. It will act autonomously for you, and it will be your great assistant in multiple ways. So in general, when I put it into one sentence, you can think of it like AI agents think, act, and learn, while AI assistant wait and responds. So in the next videos, I will be talking more about the RAG vector databases and how it is all connected and how it is actually working on live examples. Similarly, I will be building the AI agents, so stay tuned up for more and see you in the next videos.